Next, we'll take a look at the chain rule. And the chain rule is also known as the outside inside derivative. And the chain rule is used when you have a composition of functions. So before we get into the actual formulas, let's take a look at a formal example. So here we have the same equation but written in different ways. Y is equal to 9x to the fourth power plus 6x squared plus 1. And we also have y is equal to 3x squared plus 1 quantity squared. And these two functions are exactly the same. If you were to take 3x squared plus 1 squared, which means if you were to multiply 3x squared plus 1 times 3x squared plus 1, you would get 9x to the 4 plus 6x squared plus 1. What we see on the left-hand side, this is a trinomial, right? It's the fourth degree trinomial. What we see on the right-hand side is actually a composition of functions. Our outermost equation is a quadratic. Our innermost equation is also a quadratic. So this would be a composition of two quadratic functions. When we find the derivative, since this is the same equation just written differently, our derivatives must be the same. So let's just see how this works. So we're going to take the left-hand side, 9x to the fourth plus 6x squared plus 1, and we're going to find the derivative. So I'm going to use the power rule. So the derivative of 9x to the fourth power is 36x cubed. The derivative of 6x squared is 12x. And the derivative of any constant is 0. So this is the derivative, which should also be the same derivative for our function on the right-hand side. So in order to find a derivative for this composition, we must use the chain rule, which is the outside-inside derivative. So first, I'm going to take the derivative for the outermost function, which is this quadratic. So I'm going to use the power rule. I'm going to take 2. I'm going to treat that as a multiplier. And I'm going to leave the innermost function as it stands. So this is the outside derivative. Times, and now I'm going to take the derivative for the innermost function. So the derivative of 3x squared plus 1, that should give us 6x. And this is the inside derivative. Now I'm going to simply multiply these two functions together. So first I'm going to distribute 2 times 3x squared is going to give us 6x squared. 2 times 1 is 2. And then we're going to multiply that by 6x. So I'm going to use the distributive property. So 6x times 6x squared is 36x cubed. 6x times 2 is 12x. So notice that the derivatives are exactly the same. Now let's take a look at a couple of examples. All right, so let's take a look at the first example. So we have find dy dx if y is equal to 3x cubed plus 5x plus 2 quantity cubed. So to find this derivative, we must use the chain rule. Here is the chain rule formally. It's dy dx, so that's the derivative of the function y with respect to x. That's equal to du dx, so this is the derivative for the function u, well, with respect to x, times dy du. So this is the derivative of the function y with respect to u. Right, so this is the actual chain rule. So let's see how this applies in our problem. So we have y is equal to 3x squared plus 5x plus 2 quantity cubed. So here are the steps. Since we have a composition of function, our outermost function is a cubic and our innermost function is a quadratic. The first thing we want to do is make a substitution. So we're always going to substitute that innermost function with the variable u. So when we substitute, we always substitute out the innermost function. So I'm going to let u equal to 3x squared plus 5x plus 2. And now I can simply let y equal to u to the third power. Right, so we substituted u for 3x squared plus 5x plus 2. And now we can simply let y equal to u cubed. Step 2 is to find the derivatives. So when I find the derivative for my innermost function, I want to find the derivative of u with respect to x. So I'm going to use the power rule for each term. So the derivative with respect to x for 3x squared is 6x plus the derivative of 5x with respect to x is 5, and the derivative of any constant is 0. So we found du dx, which is in our chain rule. Okay, now it really doesn't matter which one of these comes first because you're multiplying. So we found one piece of our chain rule. I'm now going to find the derivative for our second function. So we're going to find the derivative of y with respect to u. So the derivative with respect to u for u to the third power is 3u squared. So we found dy du, which is another piece of our chain rule. So our third step is to actually use the chain rule. So the chain rule says that dy dx, that's equal to du dx times dy du. So we're going to take those two derivatives and we're going to multiply. So dy dx, that's going to equal to du dx. So du dx is 6x plus 5 times, so our parentheses allude to multiplication, dy du, which is 3. So I'm simply going to put 3 in front of that first factor, times u squared. So notice that our original function is written in terms of x, right? There are no u's in our original function. So therefore, our derivative must be in the original variable x. So in order to rewrite this in the original variable x, next we have to back substitute. So step number 4 is to back substitute. Because recall, we've substituted u in our very first step is 3x squared plus 5x plus 2, and now I'm simply going to back substitute it. So we have dy dx, that's equal to 3 times 6x plus 5, and we're going to back substitute u as 3x squared plus 5x plus 2 quantity square. And this is our derivative. Now in these instances, we can leave the derivative in its factored form. We don't actually have to go the extra step and multiply all of these factors together. All right, let's look at one last example. Now, in some of the problems, you may be given the pieces already substituted out. So in this example, we're actually finding the derivative, and we have y is equal to 2u squared minus 5u plus 2. Since the substitution has already been performed, in this case, our first step is to find the derivatives. So for this first equation, we're going to find the derivative of the function y with respect to u. So we're going to find dy du. So in finding derivative for 2u squared with respect to u, we have 4u minus the derivative with respect to u for 5u is 5, and the derivative for any constant is 0. We're now going to find a derivative for our second function, the derivative of u with respect to x. So the derivative of 3x plus 6 is simply 3. The next step is to use the chain rule. So recall that the chain rule is dy dx. That's equal to du dx times dy du. Right. So keep in mind, since this is multiplication, it really doesn't matter which derivative we find first. All right, so now we're going to simply multiply everything together. So we have dy dx, that's equal to du dx, which is 3, times dy du, which is 4u minus 5. And I'm going to simplify. I'm going to multiply or distribute 3. So this gives us 12u minus 15. Our last step is to now back substitute, because recall that our original function is in terms of x, so our derivative must be in terms of x. So our third step is to back substitute. So dy dx is equal to 12 times u, and recall that u is 3x plus 6 minus 15. So I'm going to distribute 12. So this is 36x plus 72 minus 15. And now I'm going to simplify 72 minus 15. So we have our derivative as 36x plus 57.